End users only get the data and information which is present at the external view, but they can't view whatever they have in the database. When it comes to the logical data independence, at that time, whatever I am changing in the logical level or a conceptual level, that should not affect on the content of this external level. We are going to have a mapping because whatever the query that I am giving can't be understood by the Dbms. So that needs to be converted into its understandable language. Hello everybody, a warm welcome to one and all. Welcome back to the session 2 of chapter 2 data modeling of unit 1 of B.C.A semester 4 subject called database management system. In short, it will be considered as Dbms. I am Rohini TS, Department of Computer Science, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. Previous session of this chapter, we had discussed regarding the data model. So as we all know that when it comes to the data model, there we have to remember 3 words, isn't it? That is what? SOC, that specifies the structure of a database, and also it specifies the operations that we are going to use for the manipulation of database, and also the constraint that needs to be satisfied by the database. So if it is describing, then we are going to call that concept as data models. And also we had discussed regarding the categories of data models. Totally it has 3 categories: conceptual, physical and representational or implementational. All those 3 are the categories of the data models, and we got to know regarding the schemas as well as the instances. So instances is also considered as occurrences, or it is also considered as a snapshot. The data which is present at a particular time in a database will be considered as a instance. And also we got to know that regarding schemas and instances, and also we had discussed regarding the database schema versus database state. So these instances or state both are same, and we had discussed regarding the schemas versus instances or occurrences or a snapshot of a database. That is a data whatever is present on a actual time, that will be considered as what? Database state or an instances. So in our today's session, we are going to learn with the 3 schema architecture, and also we'll see what do you mean by data independence. So as we all know that already we had discussed regarding the characteristics of database. Can you just recall what are the characteristics we have? So if I consider that, first is what? Insulation between the data and program independence, isn't it? Insulation of data and program. And what is the second characteristics? It allows multiple view. It allows multiple view. And also we have one more characteristic, that is use of catalog. So that describes the complete structure of a database. So these are the characteristics that we have with respect to the database. So by making use of this characteristics, or in order to specify or in order to represent all these characteristics of a database, we are going to have this 3 schema architecture or a 3-level architecture. Along with that, I will be discussing regarding the data independence. So now we'll see about the 3 schema architecture. So as I told, in order to satisfy the characteristics of a database, or in order to support the Dbms characteristic, we are going to use this 3 schema architecture. Along with that, it includes program data independence. Mainly it supports the multiple views of a data, and how each level will going to support the view of a data and how it is working along with the diagram we'll see now. So here, this is the 3 schema architecture of a Dbms. So here you can see that it has 3 levels. One is external level, conceptual level, and also we have internal level. So whenever you see this diagram, whenever you see that shape, you have to remember that is a database that will going to store some data and information within that. So that is what database is present as internal level, and also we are going to call that as a internal schema. So when it comes to the above of that internal schema, we have a conceptual schema. And there must be a mapping between this conceptual and internal level. That is what we are using this bidirectional signal. And also we have one more level, that is higher level, that includes external level. So in the external level, we have many external views, and also we have end user. The person, one who is using the database, will be considered as a end users, and already we had discussed regarding the types of end users. So here, in order to get a connection or a mapping between this conceptual schema and external view, then there is a external or conceptual mapping. So now we'll start with the lower level. That is what we are going to call that as an internal level as well as physical level. So if you consider the stored database, the stored database will logically related data it will going to store. When it comes to the physical level or an internal level, that will going to store the database, like how the data is stored actually. So that will be, that information is stored in the stored Dbms or at the internal level. So this showcases how records has been stored and what is the ordering of that records and what kind of data it includes. So all these will going to be used by the database administrator or will going to be used by the application programmer. So mainly it will be at more abstraction. So in that internal level, it has more abstraction. It can't be accessed and can't be used by the end user. So end users only get the data and information which is present at the external view, but they can't view whatever they have in the database, but they can get the benefit out of it. They can retrieve the values and information which is present in the database, but they can't see how the data has been arranged, how the records has been ordered. So that can't be seen by the user. And completely it specifies the how data has been stored in the database, and also it provides the access path. That means how this data, whatever is present in the internal database, can be accessed by the higher level. That is what it has. It will going to provide the access path. With the help of that path, this conceptual schema will going to fetch the data from this internal database. So that is we are at the level called conceptual schema. So in this conceptual schema, it will going to work based on the entity relationship module. That means here it will going to represent every object as an entity. So as we all discussed in the previous session, we got to know what is an entity, right? So I can consider anything as an object, and each object is a real world instance, and that instance can be represented as an entity, and each entity will going to have its own properties. It will going to have its own characteristics. Then I can consider that as an attribute. And also we have relationship between one entity to another entity that completely specify how objects or an entity is related from one entity to another entity in a database. So that will going to be takes place in the conceptual schema. So in this conceptual schema, it will going to have somehow a lesser abstraction than this internal schema. So as the levels go high, at that time abstraction will be more. As the levels comes down, abstraction will be very high. So as the levels goes high, at that time abstraction will be more. So when it comes to the conceptual schema, it will going to have less abstraction than this external level, and it has more abstraction than this stored database or at the internal schema. So as I told, in the conceptual schema, we have an entity relationship as well as we have an attribute that represents the relationship between one entity to another entity, how it will going to be implemented, how data need to be fetched from the database, and what kind of data needs to be reached to the user or an end user. Everything will going to be done at the second level called conceptual schema, and we are going to call that level as conceptual level. So at last we have main level or a first level, that is external level. So in the external level, the abstraction will be more. So user will not going to get to know what is happening inside here, but they can understood what is happening in the conceptual schema, but they don't have an access to this internal schema. So in the end user, already we know the types of end user, and each end user will going to get the benefit, like based on the type of view what they want. So based on that, they are going to access the data and information which is present in the internal schema. Then this conceptual schema will going to provide an access path. This internal schema provides an access path. With the help of that access path, this conceptual schema will going to get the data and information from the internal schema and help out reach that to the end user. So here abstraction will be more. So it is also considered as what? External view. How the data is viewed by the user, on what format or what kind of report they are getting the resultant. And also here we can see that we have a mapping. So as I told, I can't understand computer language and computer can't understand our language, because computer or computer memory, every data will going to be stored in zeros and ones. So here first end user have to analyze. You just imagine I have a database, within that I have some content. I wanted to retrieve it. I wanted to write a query for that, right? So I'm asking some question. That means I'm asking database, give me what a number of employees in my organization. That is what my query is all about. You just imagine that way. So after that, that request will going to be reached to the conceptual schema. So this conceptual schema will going to convert that as a request. Okay. So here I am going to send in the external level, I will send that query as a question against the request to this conceptual schema. So this conceptual schema will going to take all those requests from the external level and make it reach to the internal schema. So when it reach to the internal schema with the help of this access path, at that time this stored database will going to search for all the details which is looking by the end user. Then again this stored database will going to fetch the data and information whatever asked by the end user. So once the query is processed, once the resultant is done, at that time I can't send the data and information which is in the machine language. So that needs to be understood by the computer, but whatever the data that is producing should be understood by the end user. Again it will going to be mapped to the end user's view. So here whatever the data and information that I require as per the request of this end user will going to be reached to the internal level schema with the help of this conceptual schema. After that, the database will going to process all those things. Then it will send the data back to the conceptual schema. Again this conceptual schema will going to understand that yes, this is what their request or queries. Then they are going to send this as a response back to the external view or an end user. So at this point of time, end user or an external level user will not get to know what has happened internally. They just know we have some data, I am going to get the resultant. So in between what mapping had happened, that will not be understood or that will not be disclosed to the end user. That is what we have level to level abstraction. So here in the external level we have more abstraction. In the conceptual level we have lesser abstraction than this external level. User may understand what is happening in the conceptual schema, what is relationship between one object to another object, but they don't have a accessibility to this internal schema, because internal schema is what there we are going to have a complete storage of it, records or files, whatever the data we have, physically or actual data will going to be stored in this internal schema. This is what you have to remember. For that purpose, we are going to have a mapping, because whatever the query that I am giving can't be understood by the Dbms. So that needs to be converted into its understandable language. Then whatever the manipulation has been done, after that it has to send the resultant back to the external view or to the external level. Then that resultant should be understood by the user. For that purpose, we are going to have this mapping. So whatever happening in between the internal schema and conceptual schema, so the conversion between the request and response will be takes place with the help of this conceptual or internal mapping. So after the exchange of data between this external level and conceptual schema, for that purpose we have this external or conceptual mapping. So it will be of like this kind. So then it will send the resultant back to the user, and user will going to see the resultant as per their requirement. This is how 3 schema architecture will going to work. So now we'll see about each level right now. So defines the DBMS schemas at 3 level. So this 3 schema architecture will going to defines the DBMS schemas. Already we know the schema. What is that? That is a representation of a description of a database in some illustrative manner. So that is what schema is all about. So that schema can be represented in 3 levels. So one is what? First is internal schema at the internal level. This is the internal level. What will going to happen here? This describes the physical storage structures and access path. What it includes? It stores or it describes the physical storage structure, how the records has been arranged, what is the its index, what is the order, what is the data type it includes. That is all going to be described in the internal schema or at the internal level. And also we have a access path. As I told, if I don't know the route how to reach to that database, I will not able to access the content. But if I know its path, if I know where it is present actually, then with the help of that access path, I can fetch the data. So that it will going to describe the storage structure along with its access path. So that includes indexes. So if you see the index of your textbook, so there they are going to give you the serial number, chapter name as well as page number. So if I just look into that page number and if I turn that page, exactly I can get that chapter. That is what it is giving a part to us in order to reach the particular content. In the same way, we are going to have a indexes here that uses a physical data model. Already we know regarding this physical data model. There I have described everything regarding how the record is organized and how it will be indexed, right? So with the help of that, we are going to fetch the stored structure of the physical level. So what is the second level we have? That is conceptual schema at a conceptual level. Then why we are going to use that? In order to describe the structure and constraint. So what it define? It defines the structure and constraint for the whole database for a community of user. So if I'm sending some request, that request need to be satisfied the structure and it has to obey the constraint whatever they are following. That is what here in the conceptual schema at the conceptual level, it will going to describe what is the structure of a DBMS. So then only with the help of access path, I can access the data. So as per my schemas or as per my constraint, I can retrieve the data and I can make it reach to the external level. So that this describes the structure and constraints for the whole database for a community of end user. That community of end user in the sense what? There can be different types of user. So we have an administrator, we have a application developer, designer, and also we have an analyst. So for each user, its perspective or view of a data will be different than differs than one another, right? So based on that, it will provide a schema as well as it provides a structure and constraints of based on the user and uses a conceptual or an implementation data model. Which data model it is using? It is using conceptual or implementation data model. Everything will going to be worked based on the ER diagram. That is what? Entity relationship. So at the last level, that is external schemas at the external level. We have external schema at external level. What it describes then? So that describes the various user views. As I told, different user will going to have a different views. Like their GUI will be different from one user to another user. So usually uses the same data model as the conceptual schema. So that is also going to use the implementation data model. So these are the 3 levels we have in the 3 schema architecture. Mainly what is that? In order to suppress the detailing of accessing or manipulation of a content from the user. That means I just wanted to hide what is happening internally and I just wanted to give the resultant what they require. For that purpose, we are going to have this 3 level or 3 schema architecture. Then what is the use of having a mapping? Already I told you regarding this mapping. So mapping among the schema levels are needed in order to transform the request and data. So as I told, if I am giving some queries that can't be understood by the database directly, that needs to be what transmitted as a request in the conceptual level, then that has to reach to the internal level with the help of access path. Then only they are going to process. Again that resultant needs to be reached to the end user as the language that they can understand. That is what here. And also here program refers to an external schema and are mapped by the Dbms to the internal schema for the execution. For the mapping, external schema will going to be mapped with the internal schema in order to perform some of the operation. I am going to use some of the programming language. You can take the SQL as a programming language. So with the help of that programming language, I am accessing the content of this internal schema and I can get the resultant back to the external schema or level. So that data extracted from the internal DBMS level is reformatted to match the user's external view. So as I told, user can't understand what is the resultant that is giving without doing any transformation. So then this transformation is required or reformatting is required in order to make the user understand as per their requirement. So example, you can take the formatting of the resultants of an SQL query for the display in a web page. So if you right click on that web page and if you see the view source code, at that time you would not understand what is there in the complete web page, but I can get the resultant as a web page. I can see whatever the image I want, I can get the videos, photos, that and all I can get. But if I right click on that web page and if I click on that view source code, you just try this. You have any of the web page, just right click that and you can see the option view source code. You just click on that. That will going to take you to the HTML programming along with some of the CSS and all those stuffs will be there. Okay. So at the time if you see that, you couldn't understand any of the content over there. But if you see the web page, at the time you will going to get the resultant as per your requirement. That is what mapping is required in order to do all those reformatting of a data and request. So this is regarding what? 3 schema architecture. We'll see the next topic, that is data independence. Already we got to know regarding the 3 schema architecture, right? So in the 3 schema architecture, we have 3 levels. One is external level and we have a conceptual or logical level, and also we have a physical or internal level. Let me write that first. We have a external level, that is first or high abstraction level, and also we have a conceptual or that can be considered as what? Logical level, that is in between. So at last we have a physical level or that will be considered as a internal level. Okay, so these 3 levels we have. So then how can I use this data independence or how can I represent this data independence with the help of this 3 schema architecture? So you just imagine I have a building, in that I have 3 floors. Okay, so if I am doing any construction work or if I am doing any renovation with respect to the ground floor, that should not affect on the second floor. That is what data independence is all about. So here, if I am modifying the content or if I am changing the schema of one level, that should not affect on the schema of another level. That is what we are going to call that as a data independence. When it is taking place in the logical level, when it is taking place in the physical level, then we are going to call that as a logical data independence and physical data independence respectively. So we'll see that with respect to the logical data independence, that comes in between the external level and physical level. So here we are having a data independence to the higher level, not to the lower level. So that when it comes to the logical data independence, at that time whatever I am changing in the logical level or a conceptual level, that should not affect on the content of this external level. That you have to remember. It should be like this. Okay, but when it comes to the physical data independence, at the time if I am changing anything or any content in the physical level, then that should not affect on the conceptual level. We'll see now. The capacity to change the conceptual schema without having to change the external schemas and their associated application program. If I wanted to change the schema of this conceptual level or a logical level, so whatever I am changing with respect to the schema, that should not allow me or that should not affect on changing the content of this external schema. That means it should not change the content or it should not affect to the external schemas and their application program which will going to be used by the user. Best example is your WhatsApp or any of the social media. updation. Okay, so if you are updating that, so logically it is changing its schema, but that will not going to affect the use of your WhatsApp or any of the social media. So you can update together, you can use that. That means what? Whatever the changes they are making with respect to the logical level, that is not affecting on the external level. That kind of data independence will be considered as what? Logical data independence. So in the logical data independence, at that time, why I am going to change some content in the logical data independence? Mainly for the updation of a database, like in the conceptual level or in the logical level, I have an entity, I have an attribute, and I have a relation between one entity to another entity. Like I am going to add some new content, or I can change the structure of my database, or I can change my constraint, or I can update my constraint. I can make that more stricter than the previous one. That is what I am updating my database. Okay, that is in the logical level. But if I am doing all those things, that should not affect on the view of a external level. Then we are going to call that as a logical data independence. So now we'll see about the second one, which is related to physical data independence. As I told, it will be of the higher level. So then I can't come to any other next level than this physical. So then the capacity to change the internal schema. So when it comes to the internal schema, what we have here? Here we have a actual data, right? So here we have a actual data. Along with that, I have a database here. I have a content in the database. If I am making any modification to that internal schema without having to change the conceptual schema, if I am doing some changes with respect to my records and ordering of that record, indexes of that record or access bar, that should not affect, or that should not change the constraint, or that should not change the structure of a data in the conceptual or a logical level. That will be considered as what? Physical data independence. So for example, if I wanted to change the index, or if I wanted to rearrange it again, or if I wanted to change the file structure, so at that time if I am doing all those modification, then the content of that physical level should not affect the working procedure of this logical level. Then I am going to call that as a physical data independence. So when a schema at a lower level is changed, only the mapping between this schema and higher level schema needs to be changed in a Dbms that fully supports the data independence. So when I am changing the content of my lower level, for example, if I consider a physical or internal level, if I am changing any content over there, at that time, so only mapping between that schema and higher level schema needs to be changed, and it should not affect on any other content in the Dbms. Then only we can say that it supports the data independence, and we can't do any modification with respect to what external level, because that is highest abstraction. I don't have any further level above that external level, so I can't have any mapping. So if I don't have mapping, then it is somehow impossible to do the data independence, so that the higher level schemas themselves are unchanged. Okay, so only we are going to do the modification with respect to internal or conceptual, so that the application program need not to be changed, since they refers to the external schemas. Application program will not going to be changed, only its structure, only its constraints and rules and regulation, and its internal storage of a file record and its index will going to be changed. And if you consider which is more difficult to, in order to illustrate this independent, you can consider this logical data independence will be more stricter than this physical data independence, and somehow it will be considered as a difficult task in order to have a changes with respect to the logical level which should not affect on the external level or at the external view. So this is regarding what? Data independence. I hope you all understood regarding this session. In my coming session, I will be discussing regarding the different database languages. Along with that, we'll see about the Dbms interfaces. I hope you all understood. Let me meet you in the next session. Until that, keep learning, keep on growing. Thank you.